So, hello everybody, I'm István from Nokia Bell Labs. That means that I'm a researcher. I'm not doing products. We are not making products in Nokia. We are trying to help strategists to figure out what will be the next wave of technology that is relevant to Nokia. And we also try to create the next wave of technology that will be relevant in the telco domain, hopefully. Bell Labs, by the way, has very big traditions. It is the same Bell Labs where Brian Kernighan and Ken Thompson worked on Unix, and where Dennis Ritchie wrote the famous C programming language book and invented the C programming language. That is where the transistor was invented, and I think even the laser. We have 10 Nobel Prizes, but I do not have any, so I do not have a Nobel Prize, unfortunately, yet. So, before we dive in, I will talk about one CNCF project in particular called CAPT, but I want to have some sense of how relevant will it be to all of you. So by show of hands, how many of you have ever written a Kubernetes controller? How many per week? Okay, just kidding. Okay, that is not so. How many of you knows what a Kubernetes controller is? Okay, that is much better. How many of you have heard the term GitOps? Oh, that is good. That is even more. Come on. More people know what GitOps is than what a Kubernetes controller. Wow, it is strange for me. Okay, how many of you use GitOps in production? That is my last question. Okay, there are some people. That is good. So for those of you who answered yes for this last question, there is a chance that this presentation will be directly useful. So that is, hopefully, you will learn something that you can use tomorrow in your workday. For the majority, the other ones, I hope that I will be able to introduce some concepts that you will remember in the future when you are in a situation when when you can apply it, and then it will be useful to you. Having said that, the topic for today for me is a project called CAPT, or KPT. I will refer to it as CAPT. And this is one of the new kids in the block. It was accepted as a sandbox project by CNCF quite recently. And it has several parts. So it is a big umbrella project. I listed the components here. There is a CLI. There are concepts and principles related to it. There is multiple SDKs related to it. It has its own packaging format. It has its own GitOps solution, everything else. I will not go through all of these today. I do not have the time, and it would be even more boring than this presentation will be. But I will want to focus, since I was told that the topic for today is Kubernetes-related development. I don't know if it means developing the Kubernetes ecosystem itself or developing over Kubernetes, but what I will focus today, how this project and all of these parts will enable us to write a whole new class of Kubernetes native applications. So that is what I want to focus on today. But what does CAPT will give us? First of all, what makes, in my definition, an application Kubernetes native? My definition is simple. If it has at least one Kubernetes controller in it, or at least something that follows the Kubernetes controller pattern, it is Kubernetes native, from my intents and purposes. So, based on my definition, Kubernetes itself is Kubernetes native, since most of its components are Kubernetes controllers. The only exceptions are the API server and the etcd backing up the API server, but everything else on this quite outdated picture, like the controller manager, like the kubelet, the kubeproxy, the scheduler, all of these are Kubernetes controllers. I will not go into the details of the Kubernetes architecture, bear with me. So, but what is a Kubernetes controller? And now I know that most of you know what a Kubernetes controller it is. So I will just briefly very quickly go through what I think is important in the Kubernetes controller pattern. It will be a repetition for you. However, later I will want to draw an analogy. So just bear with me, we will get there. I want to use it as an analogy later. So now I will go through this slide. Okay, so what is a Kubernetes controller? My favorite definition is written on the slide. And I really like this definition. It is just a fancy term for an application that sends CRUD operations to the Kubernetes API. So it's a service that creates, reads, updates, deletes Kubernetes resources via the Kubernetes API. That sounds nice, but actually there is a little bit more to a Kubernetes controller. There are some things that it has to do in order to be called a Kubernetes controller. And that is that each and every Kubernetes controller tracks a Kubernetes resource, a Kubernetes object. And it will interpret its contents as a desired state that should be applied to some part of the world. For example, if it is the replica set controller that we all know and love, then the resource that we are tracking, of course, is the replica set resource, and the desired state in it would be something like I want exactly 2 replicas of this pod template to exist in this Kubernetes cluster, maybe in this namespace, sorry. But the controller of the replica set will do, it will read this desired state, and it will collect information via the Kubernetes API regarding how many of these pods are actually deployed in the Kubernetes cluster, and if it is not exactly 2, then it will create a new one, delete one. We all know how it works. It will update the KRM resources, the Kubernetes resources via the Kubernetes API. However, not all of the Kubernetes clusters work these days. These works like this. If all of them would work like this, then nothing would ever change except the etcd, the records in the etcd, but we actually want to start containers, create cloud resources, things like that. So there are other kinds of Kubernetes controllers that work exactly the same. The only difference is that the desired state that is expressed in the Kubernetes, the primary Kubernetes resource that it tracks, applies to something that is outside of the Kubernetes cluster, but otherwise everything works the same. It reads the desired state, it collects information of the actual state of the world, compares the 2 together. If there is a difference, then it tries to push the world into the direction of the desired state. And it does it in an infinite loop. So some examples just to, I know that you know this, but with the external DNS, quite recent, the external DNS controller, what it will do, it has some desired state, and then it will compare this to DNS records in some external DNS, like route 53, and do some modifications if it is required. Or it can be a controller for a cloud resource, let it be any cloud. Or if you consider the container runtime not part of Kubernetes, that even the pod resources like this, that it will compare the controller of the pod resource, that is the kubelet, will compare the pod template in the pod resource, the desired state, with the actual running containers, and it will do some modifications if it is required. But to show you an example when it is not some software system that we are automating, that we are modifying, you can write a Kubernetes resource that defines the tilt of a physical antenna. We are in telco. So, and if you change that resource in Kubernetes, then there will be a controller that will actually move the antenna to the desired position. So that is also possible totally by using this pattern. That's all, and I really think that this extensibility will gives most of the power to the Kubernetes system. But Isti, we had closed loops before. We had reconciliation loops before. Why is it so special? What is special with Kubernetes? What I think Kubernetes adds to the picture besides desired states and the corresponding reconciliation loop, is a nice framework that allows these small reconciliation loops to cooperate together towards a common goal. So the really powerful thing is that you can design these control loops in a highly choreographed way that control loops that are not talking to each other at all still pushes the world toward the same common goal. I will very, very quickly, that is everybody here knows, so I will very, very quickly go through this replica set example that I already mentioned, that when you create a replica set object, then the controller for the replica set will detect that, oh, I should have one replica, but I have 0, so it will create a new resource in etcd called the pod. Then another controller that is called the Kubernetes scheduler will notice that, oh, I have a pod resource in etcd, but the node field is empty. Oh, and then I do my thing. It does the scheduling and writes the result back into the field, like node 3. And there is a third Kubernetes controller called the kubelet. It will notice that, oh, I have a pod resource in etcd with the field of node 3, but there are no containers running in the runtime on my node, so it will actually start the container. So we had 3 controllers not talking to each other at all. Still, at the end, we fulfilled the desired state that was expressed in the replica set. And that Kubernetes makes this possible and makes it easy to do. That is one of the things that makes Kubernetes really powerful. Okay, we are getting there, so bear with me, we are getting there. I know that I haven't talked about kept yet, and we are approaching the subject, let's say, but I still have some slides before that. Because Kubernetes is so powerful, not just as a container orchestrator, but I showed you examples that it can be used for configuring physical antennas as well. It is used, there are an increasing number of Kubernetes clusters in each of us company, and there is an increasing number of Kubernetes resources that we have to manage. And thus, a lot of infrastructure operators, platform administrators, whatever they called, will find that these common imperative tools like kubectl or the Helm CLI or GUIs, various GUIs that you can use to create resources in Kubernetes clusters are not enough to manage all of this growing number of clusters and the growing number of resources in it. Because using those will result in the drift of the configuration of different clusters. It is very hard to maintain company-wide policies like security policies or any kind of policies that your boss makes you to apply to all of your clusters. So basically, doing all of these via these CLI tools becomes a challenge. Just 1 minute. Sorry. So, and to address this challenge, now we arrived here, it becomes increasingly common, more and more common to use a declarative approach instead to manage this growing complexity, this growing number of resources and clusters. There are some buzzwords that I wrote on these slides, and I was very glad to see that GitOps is something that you have heard of. If you know what GitOps is, then I'm pretty sure that you also heard about infrastructure as a code, maybe Terraform, configuration as a code, and configuration as a data. Maybe you haven't heard about that, but I will not go through all of these except the last 2. So I will talk about configuration as a data a bit later. But whatever, the common property of all of these is that the idea behind them is to apply the same principle that we just talked about, that we know and love, that drives Kubernetes itself, to applies this idea to infrastructure management, lifecycle management, and configuration management of the applications running in Kubernetes clusters. Okay, let's talk about GitOps. Okay, first, so how GitOps applies this concept to these various management problems is that at least if you use GitOps in a Kubernetes environment, it usually means that the GitOps tool will reconcile Kubernetes resources that are presented in Kubernetes resource manifests stored in Git, in text files, reconcile that as the single source of truth towards some actual Kubernetes cluster. Compares them. If there is a difference, then it will use the resources stored in Git and will overwrite everything in the cluster so that it will match the desired state. This presentation is not about GitOps. I'm not trying to convince you to use GitOps. It might not apply to you. It might not make sense to you. But on one hand, if you manage enough complexity, manage enough clusters, enough resources, and you want to avoid drifting all of these clusters from cattle, and you want to avoid to become pets or snowflakes or whatever else, and this is definitely something that we do not want in the cloud-native world, to have a lot of pets instead of a lot of cattle, then hopefully you will naturally use GitOps. Or it might happen in a corporate environment that your boss makes you to use GitOps, because it happens in these environments that your boss will say to you that you have no choice, we are using GitOps, you have to use it. He may have a good reason for that, or maybe he just read it in some blog post and he thinks that this is the new fad, this is the new, I don't know, fancy hype thing. Whatever, you have to use it. So if you have to use it, then what happens that you still want to automate your management tasks, because that is what we as engineers do. We want to automate tasks. You still can edit YAML files in a text editor directly, manually, and then commit and push it into a Git repo, and what the GitOps tool will do for you, like Argo CD that was mentioned. There are multiple GitOps tools, by the way, out there. They are production grade. You can choose any of those. You can edit those manifests manually. But what happens if you want to automate things? You want to automate your processes. Well, what would normally happen is in a Kubernetes environment, if you want to automate something, you write a Kubernetes controller, exactly like I was talking about. However, a Kubernetes controller usually tries to modify a Kubernetes resource in the cluster. But now you are out of luck. If your controller modifies something in the cluster, then the GitOps tool's reconciliation loop will detect that, oh, there is a drift, and it will overwrite your change so that it will match the source of truth that is in Git. So you cannot use the conventional Kubernetes controllers here. Yes. So basically you are out of luck. And now we arrived. That is why then the project that I want to talk about comes into the picture, where Kept comes into the picture. As I said, Kept is a big project, so it comes with its own principles as well. It is not just a lot of tools and code, but it has its own principles even. And those principles are usually referred to as config as data. It sounds very similar to config as code, because I personally consider config as data as a subset for config as code. So it is basically the same, but with a bit more restrictions. So what are the problems that are not solved in config as code, but we still want to solve? What are those? That will drive these principles that I listed here? The first thing is that whether we are talking about infrastructure management, lifecycle management, configuration management, we want this declarative representation of desired state or source of truth to be expressed in a unified manner, meaning that we want all of these kinds of manifests to use at least partly the same schema. And in config as data, or I would say in the kept project, we are using the Kubernetes Resource Model to be this unifying schema. Schema. That means that you have to have an API version, you have to have a metadata with name, namespace, labels, annotation, everything else that you have to follow. There are some suggestions that if it is a desired state, that it should have a specification and a status. If it is instead just stores some configuration data like a config map, then it should have a field that is called the data. Whatever, all of these should follow the same structure. It should apply to the principles of the Kubernetes Resource Model that I will just refer to as KRM. It also assumes that you are using GitOps. The second principle is nothing else than you are using GitOps. You have packages in Git that is the source of truth, and you are storing this source of truth, the desired state, separate from the actual state of your system. Kept provides a component for this. It is called config sync. It is exactly like, if you know Argo CD or Flux CD, this is the same. And if you want to use kept for the purposes that I will show you, then you can use Argo CD or Flux CD. You don't have to use kept's own config sync. Okay, the third point is a bit important, so I will spend some time that I do not have right now on elaborating this. So this third principle is about separating the code that acts upon the configuration data from the configuration data itself. What does it mean in terms of KRM resources and Kubernetes resources? Okay, that is the same, sorry. So it means that you shouldn't use Helm. You shouldn't use any packaging format that uses templating. I will read also the asterisk. You shouldn't use Helm if you want to automate the modification of your you want to have an automatic process that modifies your configuration data. Because what is wrong with Helm or any other packaging format that uses templating, that it is very, very hostile to automation. You cannot even parse a Helm chart without doing the actual template substitution. The code that acts on the data is interleaved with the data itself. If you ever seen a moderately complex Helm chart, you will see something ifs and fors interleaved with your deployments and service and other Kubernetes resources. That's what I mean, that they are meshed together. That's why I cannot write an algorithm, an actual process that can interpret a Helm chart without the substitution as is, because there are no rules. So there can be an if that will delete half of the Helm chart. So I don't know. I cannot modify just one field of one type of a resource because the resource can be generated from, string manipulation code that is in the Helm chart. So that's why we do not like templating. There are actually two other problems with these kinds of solutions, less important, but for the sake of completeness. The other thing is that it's called excessive parameterization. So if you want your Helm chart to be usable in a wide range of environments, what you will end up doing is you will make everything a parameter in values YAML. Because you don't know how EKS environment or I don't know, GCP environment will differ from each other, GKE environment will differ from each other. So just to be on the safe side, you will parameterize everything, but then you lose the abstraction that use the the abstraction that, oh, this is the cert manager application that is about certificates, let's say, something like that, because you have so many of these resources. And the other thing is that the schema of your input parameters, let it be a values YAML for Helm chart or the input variables for Terraform, is different for each and every package, each and every application. There is no unification. You cannot grasp them in an automatic process. Okay, so that is why kept provides its own packaging format that is basically pure YAML and a list of so-called KRM functions that are functions that can modify those. If it sounds like suspiciously close to what Customize does with this base layer and patches that you apply to it, yes, that is the same concept. By the way, this kept packaging format, born in Google, based on the experiences from the Customize project. It is so much so that you can use these KRM functions that I do not have time to talk about in Customize as well. So it is very close to Customize. I would say that with minimal modification, you could even use Customize as a packaging format to achieve what I will talk about. Okay, so the fourth is about KRM functions. I will not have time to talk about KRM functions, so I will just skip it. We've already at least mentioned most of the parts that I listed in the beginning that are part of this kept project. Like we talked about the packaging format, we mentioned config sync as a GitOps tool, we mentioned briefly KRM functions, we told that we will not talk about Bruno or the KRM functions, but we haven't mentioned Porch yet. Sorry. So Porch stands for package orchestrator, and it is an orchestrator for kept packages. Surprise, surprise. But what Porch does for us, at least what is important for the sake of this presentation, is that it gives us an API to do CRUD operations, these create, read, update, delete operations on KRM resources that are stored in Git. That is what it does. I wanted to go through all of these. I will not have the time, but this first three basically gives you the opportunity to manipulate KRM resources like your own custom resources or even deployments and pod resources in Git that are stored in YAML files in Git. The details at this moment are not important how. But I really want to talk about, I still have 3 minutes according to this, what I still want to talk about is the last two, package variant and package variant set. So with GitOps, step back a little. So package variant simply represents a clone of an existing kept package, potentially in another repository, potentially in another Git repository. Usually, it also applies some changes to the kept package via cloning, via different methods, via KRM functions, or something called config injection. But for us, what is important for us right now is that remember that GitOps, the GitOps tools, gave us the possibility so that we can have these special kinds of Git repositories. That whenever I put a resource into this Git repository, what actually happens eventually is that I deploy something into a real Kubernetes cluster. So I can deploy something into a Kubernetes cluster just only by copying files into a special Git repo that is set up in a GitOps tool to be synchronized into an actual Kubernetes cluster. So this package variant can mean that please take this abstract kept package in like, let's say, Nokia's application repository and copy it to this deployment repository, and means that to deploy this into a Kubernetes cluster. I hope that this is understandable. So basically, with a pod resource, you are telling Kubernetes that please deploy this pod template into node 2. But what you can achieve with package variant is please deploy this application whose blueprint is in this repository to Kubernetes cluster 3. Okay, I hope that this is clear. And the package variant set is how we have pod sets like daemon sets, stateful sets, replica sets, whatever sets. A package variant set is also a set of package variants. So with the package variant set, you can say that deploy this application to all of the Kubernetes clusters that are labeled with Apple. Okay, so it is like a daemon set with a node selector, or you can define your own sets. Okay, I'll see that I have not much time, but the good thing is that I'm almost over, yes. All of this that I mentioned about different parts of the kept project, what will allow us to do, and now we arrived where I wanted, that is my point, is to take this picture, remember this picture that depicted when I explained how a Kubernetes controller works. Take this picture, and it will allow us to modify a picture in a little bit so that instead of Kubernetes controllers, it allows us to write special kind of Kubernetes controllers that I will call specializers, Kubernetes specializers, that work exactly the same as normal controllers, except that they are not modifying KRM resources in etcd via the Kubernetes API, but they are modifying KRM resources in Git via the Porch API. So you can do these special kinds of controllers. Okay, Isti, that's all nice, but you can say that. You showed us a way to write Kubernetes controllers at least 10 times more complex than the original controllers. How I write normally Kubernetes controllers. Why the heck would I use this method instead of just writing the simple, normal Kubernetes controller? So the answer to that is, I hope that, okay, the answer to that there are some situations. There are some situations when, for example, that I already mentioned, let's say that GitOps is a given to you. Because of your boss, because of your own decision, doesn't matter, but GitOps is a given. Then you have no other choice. We already went through this. You cannot modify Kubernetes resources in a cluster that is synchronized to a Git repo because the GitOps reconciler will overwrite all of your changes. Or at least you have to have special methods to take care of merging the two. That is not the topic of today. But you can do that, of course. You can do almost anything, but it is much harder. You have to pay attention. So basically, what you have to do is to modify the resources in Git instead of the cluster, and this is what you can do with a specializer. Or another use case that we face very commonly, very often in telco is that it is a requirement so that during deployment and even during operations, like when something is already deployed, during operations, we want to allow both humans and automation processes to configure the running systems. And we want them to do in collaboration. And that is also what this solution will give you, because similarly, how you collaborate over source code in Git, multiple entities can collaborate on source code with Git. You can use the same techniques like branches, tags, merges, merge requests or pull requests to do this collaboration between automation processes and human and still make something that makes sense. And the third situation you can be in when this is useful is another thing that Porch offers to you is you can make it a requirement that somebody approves each and every change. So if a new revision, a new change was introduced into Git, then before it goes into the cluster, into the Kubernetes cluster, it may require an approval. If this approval comes from a human or a long-running validation process, it is automated, but the process of the end-to-end validation of Verizon's whole network takes a whole day, then you also want to use this solution because that is basically built into the process. It is absolutely normal that we will wait a human to approve that, okay, this change can go. This is also built in Porch. Okay, so these are the the free situation, the most important situations when you can use this as these special types of Kubernetes controllers. I'm out of time by 5 minutes. So I will not, all of these I already mentioned. All of the takeaways that are written on this slide I already mentioned. Please consider using the Kubernetes control plane, not just as a container orchestration, but for any automation or control loop, even for some robotic project that you may have. Not saying that it is good for everything, but consider it. Use declarative tools, okay, we are already that. I deliberated on Helm charts, why wouldn't, when you shouldn't use them, and the short answer, you can use Helm charts, you can use templates. I'm not telling that you shouldn't use them. What I'm telling that to you is that don't use them if you want automation to modify your configuration that is in the Helm chart, that you will not be able to do with any templating packaging. And okay, the first. Okay, the last one I think is the same as the first one. Thank you. Sorry for being late. One last thing is that I see a lot of Nokia people here. Reach out to me if you are interested. I have slides on how we can use this in Nokia. Okay, this is just for the Nokia slow. Reach out to me privately, and I can tell you how we use it in research, and especially in another open source project called Nephew. Sorry, that's it. Go on. I think you were first.
So let's say you already use Flux or OCD.
Yeah.
What would be the first steps or the minimal steps to try kept interaction?
So first of all, you want to.
Let me also add that I also hate Helm.
Yes.
More passionately than you.
Yes.
But we do use customize, so we have customized.
Yes, that's a very good start. Okay, so.
How do we move together?
Okay, so the easiest way, especially if your customized setup is not really complicated, so if it is not 200 megabytes, we have seen that in Telco, so it is not, but then the easiest way to do is to convert it to a kept package. It will be easy, as I said, basically applying patches. You may already using KRM functions that we haven't, or basically you have to write some functions that emulate the patching process of customize. Why would I say to first convert them to kept packages? Because that will allow you to use this Porch API that I've mentioned. I will go back, I don't know which slide is the most, the good for this, but I mentioned the Porch API. So you can basically start to write the specializers that I've taught. Okay, you don't have to touch the Fluxcd, you said Fluxcd or Argo CD. You don't have to touch Fluxcd at all. You already have a Git repo that you can put YAML files in, play YAML files, and it will be deployed. The KRM package, as I said, it is a directory. If you have a directory with play YAML files, that is a kept package. If you add some metadata, fine, it is even better, but that is a valid kept package already. So you can already use Porch and, for example, the package variant and the package variant set that I mentioned to deploy YAML files into that special, I call it a deployment repository, that is synchronized by Flex. And then you can write the specializers, or I didn't have time for that, but you may not have to write a full-fledged Kubernetes controller specializer, but you may only have to write a KRM function. That is a containerized process that reads KRM resources on its standard in and outputs a modified list of KRM resources on its standard out, and Porch will do the invocation of these functions. So it will take care of applying your functions to your source code. And that way you can automate it. And because of Git and what Flex will, the part when I said that humans and these specializers on KRM functions can collaborate is basically provided to you by Flex. Because from Flex point of view, your automation processes will do the same as humans. Okay.
And regarding the modifications directly in this
Yes?
So how do you provide users access to a cluster? Is this a SSO or they have a...
Yes. So the component that has to access the cluster is the GitOps tool. So the reconciler that reads Git and writes it to the cluster. And you are touching on a problem because it sounds like you need a sudo server running in the cluster, and we don't like that. And config sync, that the GitOps tool that is packaged with kept, has some kind of mitigation to this problem. At least you can create Kubernetes resources for config sync that will only allow you to update just one particular namespace. You will not be able to install, for example, CRDs. There is option for that as well, but at least you have the opportunity to limit the access of the user that is able to write the Git. So that is, and Argo CD, I don't remember if there are such measures in Argo CD that where you can limit it.
Whitelisting and blacklisting.
Yes, exactly, whitelist and blacklist. So Argo CD and I don't know Flex at all, but Argo CD is a bit simpler than that in this case. But so, okay, the short answer is that your GitOps tool is the one who has to access the cluster and have to have access side. Go on.
And where do you deploy the porch?
Very good question. Okay, so I don't know if this is, okay, that doesn't help. In the management cluster. So I already told you that you have multiple clusters. Again, what I'm telling you it might be telco specific because I'm from Nokia. But what we do is that we have workload clusters and management clusters. And you will put Porch into one of the management clusters. And you will put Argo CD and config sync into a management cluster. You will run the specializers that I've told you about in the management cluster. Okay. Any other questions?
Yeah.
Go.
Also about Porch. So if I understand correctly, like Porch doesn't need access to the target clusters, right? So it's just
No.
Just responsible for the rendering pipeline and running the rendering pipeline of the
Yes.
resources?
So Porch is driven by its own API. That is a Kubernetes API, by the way, of course. And it has to have access to the Git repos. And that's it.
And then, like, if I want to expose it to developers to define their own build pipeline, so I would then deploy it to GitOps as well, or what would be like? Because I'm imagining I don't want to open the management cluster to my developers.
So that is a very big topic, and it's a very loaded question. So, but I think the simplest answer that I can give to you is that kept is the most honest answer. Kept is a relatively young project, and the development process for specializers, the development process for KRM functions is still in infancy. So we are lacking good supporting tools that can do something like that. That you have a developer and he wants to try out, for example, a specializer, a KRM function, without access to even a Q&A or a staging environment. For KRM functions, it is easy, by the way. For KRM functions, because it is easy to test, there are existing test environments for KRM functions. That it's easier. For specializers, you will need a working Porch, as you say. And I used.
So basically, what I'm saying is
I used an environment.
Like, are they already prepared to make it like self-service so that I can handle Porch?
The good news is that I am using Porch in a kind cluster on this laptop. So it is in VSL. It is a Windows machine. So I have a Linux VM inside this, and I'm running a kind cluster in it, and still Porch works. Even better, even some network functions are working that are consuming some resources. So that is the best that I can. At least that is what I did recently. It looks like that I am writing a lot of controllers, but that is not the case. To be honest, I spent more time about talking about how to write controllers than actually writing them. But That's okay. Okay.